Hello and welcome to Properties of Logarithms. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doñana Community College. This lecture is for Math 1508 Pre-Calculus at UTEP. Chapter 3, Exponential and Logarithmic Functions, comes to us from Larson's 10th edition Pre-Calculus text. This is section 3.3, Properties of Logarithms. So, let's start with the change of base formula. We saw in section 3.2, and if you need to go view that lecture, feel free, that logarithms have a base of a as long as a is positive, but not equal to 1. There's no way we could have all of those buttons on our calculators, and in fact, it used to be that we had to memorize log tables. I am happy to admit that I was not one of those that had to memorize log tables or use a slide rule, but I've seen them before. So on our calculators, on our modern technology, there has to be a way that we can evaluate these logarithms without going old school to slide rules and tables. But yet we don't have 1001 buttons because the base can be anything. So let's choose the right button here. There we go. Let's let a and b and x be positive real numbers where a is not 1 and b is not 1. So they're positive but not 1. Then log base a of x can be converted to a different base, any base, as follows. Log base a of x can be rewritten into any base, log base b of x divided by log base b of a. More importantly, it can be converted into a common log or a natural log. So notice how the base is already a subscript, right? Base, basement. It's already a little bit downstairs. And so that's the one that ends up in the denominator. Log of x divided by log of a. Natural log of x over natural log of a. So the base in the basement, it's already written a little bit lower in a subscript, so it stays down below. So we could rewrite the log as a ratio in a couple of ways. If I have log base 3 of 47, that's log of 47 over log of 3, or natural log of 47 over natural log of 3, or log base 72 of 47 over log base 72 of 3. As long as the two logs in the numerator and denominator have the same base, it's all good. Log base 1/3 of x, it's log of x over log of 1/3, or natural log of x over the natural log of 1/3. And it doesn't matter if I have numbers in both positions or a variable in one position or the other. I'm still going to have log of 3/4 divided by log of x. The base is already written lower, so it goes in the denominator. Here's showing some examples. I'm using a TI-84 graphing calculator here. Probably a TI-84 silver or plus, I don't remember. Log base 7 of 4. I can evaluate it using my calculator using log of 4 divided by log of 7 or natural log of 4 over natural log of 7. It gets the same answer either way. To 3 decimal places, I would call that 0.712. Log base 1/4 of 5, it doesn't matter. If I do log of 5 or log of 1/4, natural log of 5, natural log of 1/4, log, natural log, as long as I use the same in the numerator as I do in the denominator, that will round to negative 1.161. And similarly, for the log base 20 of 0.25, that's log of 0.25 divided by log of 20, or natural log of 0.25 divided by natural log of 20, either results in negative 0.463. I generally use natural logs as opposed to common logs for 2 reasons. One, I'm super lazy. That has 3 letters, log, and natural log has 2 letters. So that's why I write it on the chalkboard using natural log, or whiteboard, whatever board you might have. However, I also use the TI-89 calculator. Yes, I'm a Texas Instruments girl. And the TI-89 does not have a log button per se. You could type in log and it works just fine. But it does have a quick button for natural log, so it's another reason why I usually use it. Alright, so some properties of logarithms. Let a be a positive number such that a is not equal to 1, and let n be a real number. If u and v are positive real numbers, the following properties are true. Log base a of u times v equals log base a of u plus log base a of v. Think about it. If you're multiplying two things with the same base, you add their exponents. All a logarithm is an exponent. Quotient property, log base a of u over v equals log base a of u minus log base a of v. And remember, if you're dividing two things with the same base, you subtract their exponents, always numerator minus denominator. And a power property, log base a of u to the n is equal to n times log base a of u, because if you have an exponent raised to an exponent, you multiply. So the same properties we had for exponents hold for logarithms. These same properties hold for the natural logarithmic function for any base. And keep in mind that no sum or difference rules exist. So if you have log base a of u plus v, there's nothing you can do. Nothing can be done to simplify. And the way I remember this is my order of operations. Parentheses, exponents, multiply and divide, add and subtract. So inside a log, right, a log is just an exponent. If I have an exponent raised to an exponent, I turn it into multiplication. If I'm multiplying two things with the same base, I add, and if I'm dividing two things with the same base, I subtract. But what if I'm adding two things with the same base? There's nothing to jump down to in my order of operations. If I'm subtracting two things with the same base, nothing can be done to simplify these because they're at the bottom of the order of operations and there's nothing lower so that we can make it happen. So let's use the properties of logarithms to expand some expressions. Log base 3 of 10z, that's 10 times z. So that's log base 3 of 10 plus log base 3 of z. The log of 4x squared y. First I'm going to use the product property to pull all that multiplication apart. That's the log base 4 of, log base 4 plus log of x squared. That's so not the log base 4. That's log of 4 plus log of x squared plus log of y. Multiplication turns into adding the exponents. Log of 4 is fine, but the power on my x comes in front to turn into multiplication. 2 times the log of x plus log of y, which stays the same. Number 3, natural log. Remember, that's an L. It's an L, not an I. ln of 6 over the square root of x squared plus 1. I'm going to rewrite my square root as the power of 1/2. Great technique. Keep that in mind. So I'm looking at this and I have a quotient. So I'm going to subtract natural log of 6 minus the natural log of everything from the denominator. That 1/2 is an exponent, so it comes down in front into multiplication. Natural log of 6 minus 1/2 natural log of x squared plus 1. X squared plus 1 is addition inside a logarithm. Nothing can be done to simplify it. But more frequently, we're going to go the opposite way. We're going to condense to a single logarithm. Log base 5 of 8 minus log base 5 of t. The instruction is very important. A single logarithm, so your answer needs to write 1L, 1O, 1G. In this case, it's log base 5. Subtraction, I know that turns into division. So it's log base 5 of 8 over t. Going backwards, condensing to a single logarithm, I'm going to take care of powers first. So this 2 is going to become an exponent on the y. The 3 becomes an exponent on the z. Log of x minus log of y squared plus log of z cubed. And then I'm going to take 2 at a time. So log of x minus log of y squared turns into log of x divided by y squared. Now keep in mind, it's just the x that's divided by the y squared. I'm not dividing the log by the y squared. I'm writing as a single log, so that one log takes care of both pieces. And I keep my log of z cubed because I haven't done anything with it. Taking 2 at a time. Log of x over y squared plus log of z cubed turns into multiplication. If you want to tighten it up a little bit, put it into a single fraction. That's the log of xz cubed over y squared. Alright, so I'm going to do this in a couple of ways, and either answer is acceptable, it doesn't matter. But first I'm going to take care of my parentheses. Natural log of x plus 1 plus the natural log of x minus 1. Addition of two logs turns into multiplication of their arguments. So that's the natural log of x plus 1 times x minus 1. If you want, you can actually multiply them together and get the natural log of x squared minus 1. But you don't have to, you can leave it in factored form. The natural log of x minus the natural log of the mess, subtracting turns into division. So this is the natural log of x over x plus 1 times x minus 1. If you are multiplying, instead of leaving factored form, that'll just be the natural log of x over x squared minus 1. either answer should be completely acceptable. Alright, condensed to a single logarithm. Sometimes just having the answer on the screen is not enough. You need to see it step by step, so let's give it a shot here. The first thing I'm going to do is I'm going to distribute my 1/2 to both of those. So I have 1/2 log base 4 of x plus 1, and don't forget you could always hit pause if I'm going too fast, plus log base 4 of x minus 1 in parentheses plus 6 log base 4 of x. I'm going to take care of these two first, and my addition is going to, oh no I'm not. That's not what I'm going to do. I'm going to move these exponents. I'm going to take care of powers first. This is log base 4 of x plus 1 to the 1/2 plus log base 4 of x minus 1. Take care of that first. Plus log base 4 of x to the 6th. Now I'm going to take care of these two. The addition turns into multiplication. So that's log base 4 of x plus 1 to the 1/2 times x minus 1. And remember, we can't multiply these yet because the x plus 1 has a 1/2 power on it. So I can't multiply and get x squared minus 1 all to the 1/2. That's cheating. You have to handle your exponents before you can handle multiplication. So that exponent keeps us from doing multiplication here. That is a subtraction, even though it doesn't look like it. My last step, I'm going to combine these, and I will have log base 4 of x plus 1 to the 1/2 power times x minus 1 times x to the 6th. Parentheses are never a bad idea when you get a lot of things going on inside the logarithm. Try not to make it look like lag. This is actually a log, but you know, it looks like lag. Anyway, there we go. Properties of logarithms. Thanks for listening.